Hello and welcome everybody to today's talk, The Road Towards an Open Database Performance Ranking. And before we start into the technical details into database performance in the cloud, some brief words about me. So my name is Daniel. I have a research background. I studied computer science and did my PhD at the Ulm University in Germany, with a focus on evaluating large-scale distributed systems that are operated in the cloud, with a dedicated focus on distributed database systems. And the results of our research actually led to the spin-off or the startup benchANT, where I'm one of the co-founders and responsible for the product development. And having that said, let's start into the advances of database technologies for data-intensive applications, and especially their advancements over the last decade. So driven by the Web 2.0, big data, IoT, there has been a tremendous change when it comes to how to operate database systems, but also how to select database systems. So when it comes to the operation, it turns out that there's a significant move from physical resources towards elastic resources, which are cloud resources, but also edge and fog resources. On the database side, relational database systems are not anymore the only choice. There are now a plethora of choices since the database landscape has been extended with the NoSQL and also the new SQL database technologies. And this has basically led to two key aspects. So first of all, cloud resources have become the preferred solution to operate database management systems nowadays. The second one is that the idea of a one-size-fits-all database system is basically over. And with these advancements and changes in the paradigm, there come a lot of new opportunities to build even better data infrastructure or data management systems for your data-intensive application. But with this broad scope of opportunities, there also come new challenges, especially if we look at this rather simple challenge. So finding the right database technology in the cloud that provides 100,000 ops with a 5 milliseconds of latency for a data-intensive application, and to do that in a cost-efficient way. So this is actually a question that comes up quite often in any IT department, and it quite often also hits several stakeholders, but there is no clear answer to that. And why is that actually the case these days? Well, where should we actually get the data to answer this question? If we look at the database systems, so of course we can read the docs, and there we will get a lot of details on the actual feature set of the database technology, the usability capabilities, but also the tooling around the database system. But when it comes to the non-functional features, so the performance, the scalability of the system, but also the costs, it gets way more trickier. The costs, well, all the cloud providers, they have very heterogeneous cost models, but with some effort, it's of course possible to bring that together and to have a comparable cost model across different cloud providers. But when it comes to the performance of the cloud providers, but also the performance of the database systems themselves, it already gets really challenging, because this data won't be available anywhere on the cloud provider side or on the database vendor side. Of course, you will find some white papers, some blog posts, and so on, but this will basically never exactly match your use case. And the same goes for the scalability of the system. Of course, basically all providers promise to provide scalability, but having the hard numbers to actually demonstrate that, that's another point. And when talking about promises of the database vendors, well, let's have a look on their market promises. Well, basically, I just picked a few here. They're basically having, or all database vendors have basically the same pitch line. So they're, of course, the fastest database you can find. So that ranges from unparalleled performance to speed scale, high performance, even explicitly naming that outperforming some of their competitors and so on. But this is, of course, the database vendor side. And yeah, as a IT expert, of course, you want to verify that these promises are also, valid. And where could you do that? Is there already a single source of truth out there? Well, there are several really good sources to get in-depth details on database systems. For example, we have the database of databases maintained by the Carnegie Mellon University that basically provides an overview of currently all existing database systems with a lot of additional data around them when it comes to their functional features, licensing, and so on. But there is no performance data included. The same goes for the DB Engines ranking that provides you a really good ranking for the database system based on on the popularity. So speaking about popularity when it comes to Google hits, Stack Overflow mentions, and so on. But again, no real or no performance data. Of course, there's then a very common third option, which is, just ask Google. And you will always get an answer if you look, for example, for the fastest database for any kind of use case. You will find some blog posts, white papers, even research articles that are talking about a very specific use case. Also might be biased by the vendor, or just having a really small scope of the performance data available, and so on. And if we also look on the, let's say, on the golden rules, how should you assess performance issues when it comes to cloud and cloud-hosted database systems? There are also some really good golden rules by well-known companies and experts in the field. So first of all, if we look at the cloud provider side, we have, of course, AWS that highly recommends to measure the performance of applications to identify or to do the right sizing of the instances. But they do not provide you any tooling to do that by yourself. They just recommend that to you. We also have the database vendor side that basically recommends the same approach. So, for example, here we have MongoDB, and that always recommends measure everything when it comes to your use case and assume nothing. And on the IT expert level, of course, we have the well-known statement by Peter. So if you have to address a database performance challenge, do it in a methodological way and just do not settle for random Googling. And this is also actually something that we see what is currently missing out there, and especially as an open and fully transparent way to assess the performance of different database technologies in combination with different cloud providers. And this has actually brought us to build the first global database performance ranking. And in the following, I will talk in more details. First of all, why are we actually able to build such a global database performance ranking, or basically the first database performance ranking? And second, why is this global database performance ranking actually trustworthy? Why could you rely on the data? What can you do with it? And how did we achieve to provide the full transparency? These are basically the two paths I will cover in the remaining time of the talk. And starting with the question, actually, how are we able to build such a global ranking? Well, let's move one step back and just have a look at the benchmarking of database systems in order to get these performance data. And there we're going to have an explicit look on the benchmarking in the pre-cloud versus the cloud era. So in the pre-cloud era, we had the database systems sold basically as appliance. There was a clear landscape. So relational database systems were predominant. We even had, well, not forever lasting, but at least lasting benchmarks results when we think about the TPC results for example, Oracle, IBM database systems that were operated on dedicated hardware. So there were actually these tables where you could just look up which database system provides you what kind of performance, and it was rather easily comparable. Nowadays, with the cloud database era, well, we have now a plethora of cloud and database options. So already talked about the NoSQL, NewSQL, but still the relational ones offered or operated either on infrastructure or offered as database as a service and so on. The cloud and the database technology domains are rapidly evolving. So they're basically popping up new database technologies still basically every month. And also new cloud resources are thrown on the market with the same kind of release cycle. This has also led to the term of polyglot persistence. So you're using multiple different database technologies within your application stack to solve very specific needs of your application with the right database technology. But all of these has also led to the problem that there's actually no up-to-date benchmarking data. And that this is the case, well, because of these rapidly evolving technologies, because of this very widened domains on the resource, but also on the database level. And in order to get this benchmarking data, let's have a brief look on how did you get that benchmarking data in the pre-cloud era. Well, the process of benchmarking your target system was rather straightforward. So you had your database system operated on dedicated hardware. You just had to select the right benchmark, configure the benchmark, execute the workload, and process the target objectives, which were mainly performance and costs. But already setting up the right benchmark and so on is of course a challenging task, but still. If we look now in the cloud era, well, the process has been extended or has expanded. Well, of course, nowadays, first we need to allocate the resources. So either EAS resources or DBAS resources. And yeah, of course, then depending, we need to deploy and configure the database cluster. Again, select and configure the workload together with the benchmark. And then not only costs and performance, which are of course still major objectives, but also the scalability, the availability of these distributed systems are becoming very important objectives. And also probably elasticity of the database system if we're talking about auto-scaling the database system or these serverless database systems that are able to cope with growing and decreasing workload intensities. And yeah, with these additional aspects in the benchmark process and the previously mentioned frequent release cycles of new technologies, new versions, new cloud resource types, and so on, the process is also way more dynamic and continuous than it was in the pre-cloud era. And besides that, the use cases that are, or the workloads that are thrown against the database system also have evolved. So pre-cloud era was more towards the e-commerce, finance kind of workloads. Now we also have social media, IoT, AI, but also fintech workloads. And yeah, these challenges have basically brought us to identify the need for automated database benchmarking to be able to cope with these very dynamic technology domains, and in order to provide continuously performance data, which is also up to date. We have identified that there needs to be a full automation of this benchmark process. Otherwise, it won't be possible to cope with that. Yeah, with these evolving domains actually. And if we are now looking in the process of how to enable such an end-to-end benchmark automation for cloud-hosted database systems. The good thing is that, of course, we don't have to start from scratch, since over the last years, there have been a lot of tooling released, open source tool, but also commercial tools that can support you in fully automating that process. So if we look, for example, on the cloud and database orchestration tasks, there are many tools out there that can support you in doing that in a reproducible way. So we have these cloud automation or infrastructure as code tools such as Ansible, Terraform, Chef, and many more that can be applied to handle the resource allocation, database deployment and configuration, and so on. When it comes to the benchmark selection and execution, of course, the database community has been very active to move along with the new applications that are that have been evolved. And in order to cover the new workload domain, there have been a lot of work done in providing benchmark suites that cover these workloads. So there are, of course, the TPC benchmarks. There are many more, such as the Yahoo Cloud Serving benchmark, the SysBench, TLP, time series benchmark suite, Benchbase, and many, many more. So this domain is also really well covered in order to address multiple different workload types. And when it comes to processing, aggregating, and visualizing the results, of course, there are also many tools out there where you can just put all the processing in and provide really nice interactive dashboards and so on. Also just naming a few here. But of course, the challenge remains to bring all these three pillars basically together in one end-to-end framework. And this is something that has been has gained way more focus over the last 2 to 3 years. Why we started with our research earlier, so basically now 5 years ago, but we've seen that over the last 2 to 3 years, there has been way more attention to this end-to-end benchmarking. For example, MongoDB published several papers on their continuous performance evaluation or benchmarking framework that they use internally. Started with it, I think, in 2019, in order to improve their performance continuously with every new commit they may make to their source code. A rather similar approach is followed by ScyllaDB. They also provide an end-to-end benchmarking framework when it comes to run ScyllaDB benchmarks in a clustered environment. FlexiBench is coming more from the research side that focuses on the end-to-end automation of single node benchmarks in Kubernetes environments. The Mowgli framework is actually the research artifact that we've built during our academic careers. Already said, started with it for 5 years ago. And it also provides an end-to-end automation for benchmarking database systems that are operated on infrastructure as a service across with support for multi-cloud. So the framework supports, for example, OpenStack clouds, EC2, but also Google Compute Engine. And we took basically these concepts to the benchANT platform to enable a way more powerful end-to-end benchmarking as a service platform. So as already said, the Mowgli framework was basically the research artifact that is the open source version of benchANT. It is available in the spec research group tool repository with all the documentation, source code, and also easy deployable Docker containers to spin it up. And the framework basically provides you support for automating the full benchmark process that we see in the upper lane by specifying an evaluation specification, takes over the execution, and it provides you a multi-objective analysis. So it not only provides support for performance and scalability, but also for other objectives. And the data sets that you can get out the framework are built to ensure full transparency and also reproducibility by providing all the required metadata that you can actually replay the benchmarks or rebuild the benchmarks by yourself if you want to. And the framework itself, it's a microservice-based architecture with multiple components. Just a brief overview here on the architecture. It provides one central API to trigger the benchmark executions and also to get the results afterwards. And internally, there are a lot of microservices that can easily be extended or replaced to add new features to the Mowgli framework. And I will briefly go over some use cases that can be addressed with Mowgli. So as already said, you can of course apply it for database performance and scalability benchmarking by also including the aspects of different cloud resources. More details can be found in the paper and also quite some interesting results. You can also apply the framework to do elasticity benchmarking. So auto-scaling the database system under different kind of increasing, decreasing workloads and see if how the database system handles the workload spikes, and also how adding new nodes during runtime is really a good idea or not. Another use case that we covered with the framework is chaos engineering, where we inject failures in a running database system, measure how that affects the performance and also additional availability metrics at runtime. And as already said, the data sets that you can get out are pretty powerful. So what you can do with that, besides just do the sole measurements, is also build new technologies on top of that. So here we applied the data sets to build a performance model to predict the performance for specific database system, and in that case, it was Cassandra, how the performance is going to change if we increase or decrease cluster sizes that we haven't even measured yet. And we also applied the data sets to ease the database and cloud selection process by applying a multi-criteria decision-making for cloud database selection. So this was a brief overview what which use cases can be tackled with such an end-to-end automation framework. And now we brought these concepts into the benchmarking as a service platform benchANT that, of course, extends enhances the feature set of supported database systems, supported cloud providers compared to the Mowgli framework. In addition, benchANT provides an easy-to-use web interface to configure your own benchmark scenarios if you're interested in that. It also provides a powerful API to include this benchmarking framework into your CI/CD pipeline to do continuous benchmarking within your DevOps cycle. And we also added a way more powerful analytical dashboard that provides you the metrics of the target objectives, ranging from, let's say, high-level management view, aggregated scores, down to the real tech level, fine-grained time series-based data. And with this benchmarking as a service platform, you can actually enhance your DevOps cycle with these benchmark or with these data, with the performance and cost data that you can get out of it, and address several use cases ranging from pure database performance comparisons, cloud provider and resource performance comparisons, loaded stress testing, scalability, elasticity evaluations, but also do application-specific database optimizations. You can also do the version monitoring. So before rolling out a new database version, do some benchmarking in order to see that if the performance changes with rolling out a new version or not. We did that, for example, for MongoDB, and it turned out that there are still significant performance changes if new releases are, or for the new releases, for example, and they're not always, performance is not always becoming better. And of course, it can be applied to benchmark any new cloud resource offer or new database vendor. But this was it now more the from the use cases for the benchANT platform. Another thing that you can do with it is what actually brought us here today. And this is, you can build an open database performance ranking with it. Since we can now run very easily large-scale performance studies for multiple database systems, multiple cloud providers, and even apply multiple kind of workloads on these database systems within just a few clicks. We use our tool now to provide to the community the open database performance ranking. And before we dive into the ranking, some features, dimensions, and also disclaimer on the data. So the ranking is provided as open data by us, by benchANT. Currently, the performance data comprises cloud-hosted database systems, so database systems that are operated on infrastructure as a service, but also database as a service performance data. We benchmark open source, community edition, but also enterprise database versions. We have multi-cloud performance results since we applied the same workload across multiple cloud providers. Benchmarks, the measurements are actually built upon established open source available benchmark suites, so that you all also can If you work with them already or want to have a look at their source code, it's easily or it's fully transferable. And we also include in the ranking the default configurations of the database system versus the tune configurations. And tune configurations can be provided by any database vendor, by the community, or by research-driven institutes. And the first release of the Open Database Performance Ranking is available since a few weeks. We have there 9 popular relational, NoSQL, NewSQL database systems in different cluster sizes. We used 3 different virtual machine sizes on 3 cloud providers. We also have, I think, already 3 database as a service providers in there right now. The benchmark that we applied is the Yahoo Cloud Serving benchmark, which is out there, I think, now for 12 years, which provides a very, very basic performance baseline built on a read update, very simple read update workload. And the ranking is continuously extended with new databases service offers, cloud providers, and benchmarks. So the next release will cover a transactional workload with a focus on relational database systems. And after that, we're gonna publish a series of time series benchmarks, but of course with a dedicated focus on the time series database systems such as Influx, Victoria Metrics, QuestDB, Crate, but also well, general purpose database systems such as Cassandra and MongoDB. And before we actually dive into the results, one disclaimer. If we remember the statements in the beginning for the golden rules, how to select your database system, we do not want to claim that this should now be the only and golden source to select your database system and solve any kind of performance challenge. Definitely not. It should be a very, very, very first starting point if you're interested in the performance or comparing the performance of different database systems or different cloud providers. And you want some trustworthy and reproducible performance data, then our ranking should be the first step to go. But of course, you will need a lot iterations of very application-specific benchmarks afterwards to really solve performance-related challenges or do performance-related decisions. And as already said, the first release is based on the very simple Yahoo Cloud Serving benchmark workload, which barely reflects any realistic application. We also did only 1 run per benchmark or per configuration. So right now we don't have the variance in performance in it. We have it in the benchANT platform. We're thinking about adding that as additional metric in the future. So iterating or executing multiple runs, aggregating the data and build the statistical measures out of it that you can see if the cloud provider performance is stable or not. Because in the past, we also seen that some providers provide really stable results, some providers really don't. The full data set is available upon request. That will include not only the performance data, but the system metrics, the cloud and virtual machine database configurations, and all the required metadata so that you can actually replay the whole benchmark by yourself. And we will release that data in the next weeks also on GitHub. So if you're interested in that data or you want to have a really deep look on the results, feel free to already check out our GitHub repo, and there you will get notified as soon as the data is available. And having that said, now let's start into the actual ranking and the results. So the ranking, with the ranking, you have basically a lot of filters to narrow down the performance numbers that you're actually interested in. So as you can see, we have right now performance data for AWS, for Ionos Cloud, which is a German or European-based cloud provider, and for Microsoft Azure. Right now, we have these Yahoo Cloud Serving-based CRUD workload. The OLTP one is coming soon. We have 4 workload sizes that differ in the amount of concurrent threads that are executing the workload. We have these database technologies in there. And we also have, as already said, the cluster size is small, medium, large. So 1, 3, 9 nodes. And the virtual machine size is small, medium, large. And what you will get out of there is these performance numbers. So you will get the average throughput per second in operations per second. You will get the read latency. You will get the write latency. You will also get the monthly costs to operate that database system. Here, these are only the operational costs on the cloud level. There are no license costs included in the current results, since we only used open source available database systems. If license costs would be, if there would be license costs, then these would also be included in their monthly costs. And we have the throughput per cost metric, where you can actually see how many ops do you get for your dollar per second. You will also get a bit more metadata if you hover over the database system or the cloud resources. And you will get the full metadata with the dataset. And what can you actually do with such kind of performance ranking, or with that kind of performance data? Well, there are several use cases that can be covered and might be of interest to you. First of all, of course, we can do a plain performance comparison. Here we see the results for a single node database system that is deployed on AWS resources, always the same instance type. And we see that, for example, your Postgres in version 13 is really good, provides really good performance, followed by Couchbase. And yeah, you can easily now grasp, or you can easily see which provides the best throughput, which provides really low latency when it comes to read and write operations, what would be the costs, or for that kind, more interesting, what would be kind of throughput per cost ratio. We also have, as already said in there, not only database systems that are operated on infrastructure as a service, but also database as a service offers. So what you can also do is to compare, well, different database as a service offers with respect to their performance. So we have, for example, here, the Postgres RDS service on AWS and the equivalent on Azure. And we can see that when it comes to the monthly cost, they're basically same price range. But when it comes to performance in terms of throughput, AWS does a better job. When it comes to the read latency, Azure does a better job. When it comes to write latency, again, AWS does a better job. So here you can easily compare different kind of database as a service offers in with respect to their performance and cost numbers. You can also compare infrastructure as a service hosted database system versus database as a service offers. For example, we have in the first row is MongoDB that is deployed on EC2 resources, and second row, MongoDB Atlas on AWS, third row, MongoDB Atlas on Azure. Always same instance dimensions, so same number of cores in memory. And we see that even an untuned default configuration of MongoDB on EC2 resources provides the highest throughput, and of course is the cheapest way to go. It's also interesting that MongoDB on AWS, on Azure provides really bad performance. This as a side mark, so AWS, Azure it's not in general a bad performing cloud provider, but we run all these benchmarks in the North Europe region. And right now, the North Europe region is heavily overbooked when it comes to any kind of compute resources, and therefore the performance of Azure-based database systems is significantly worse than or decreased compared to, for example, AWS. An even more drastic example is when we compare Postgres on infrastructure as a service. Here we see that, for example, AWS and Ionos nearly the same performance, while Ionos is even cheaper than AWS. Nearly the same price range as AWS. But Azure is really providing really bad performance, while still with the same instance sizes and same storage backend as Ionos and AWS, or comparable. And again, as already said, this is the case because the North Europe region is highly overbooked. The the last use case you can address with that ranking is to check the database scalability. As already said, we have several cluster sizes, several virtual machine instance sizes, but also several workload intensities. And what you can see here, for example, for Cassandra, is that with the increasing workload intensities, you also get a really good scale up factor for the throughput. And even the latencies remain really stable. Read latency even decreases, while write latency is rather stable. Only with the 9-node cluster, which is the first row, you see an increase in the write latency, but still it's still a really good scaling result or scalability results for Cassandra. Of course, you can also apply the same for all the other database systems that we have in the 1, 3, and 9-node configurations. So that was a brief overview on our ranking and what you can actually do with the ranking. There are, of course, many more things that you can go into more details and so on. So feel free to check out the ranking, play with it, and reach out if you have specific questions or you want to have a look at the raw data. We also really want to see if that helps the community or how the community adapts our ranking. And therefore, we also have a community call, actually. We would love to hear what kind of database systems would you've been interested in having in the ranking. And if you're working in the database field and you know how to tune actually a database system for a very specific workload, we're happy to include your configuration in the ranking, and of course tag you there either with your name or company to provide you a platform to show that you know how to tune specific database systems. And in case you're working currently on a new benchmark, probably coming from academia, but also from industry, and you want to demonstrate its necessity and also its applicability for large scale studies, we're happy to include your benchmark and perform and add a new workload category for or based on your benchmark. And as already pointed out, you can do a lot of interesting stuff with all that performance data when it comes to machine learning based database optimization or recommender systems. And if you're building such a system and you're looking for data that can help you to train your models or enhance your recommender systems in the context of cloud and database systems, we're happy to share these performance data that we collected over the last years, and to build a great system together. So in order to conclude this talk, we'll briefly summarize the key aspects. So running benchmarks for cloud-hosted database systems has become way more complex than it was in the pre-cloud era, and it's time-consuming and also error-prone, especially if you want to do that in a transparent and reproducible way. There are a lot of rankings of database systems out there, but there is no performance-based ranking. This is why we applied benchANT to provide the first database performance ranking, and is outlined with also this first benchmarking as a service platform. We have been able to build the first performance ranking, and the ranking is continuously extended. The next release is already set is on time series database systems and also on relational workloads for relational database systems. And with that, I hope I got you interested in database performance data and showed you a way how you can ease the benchmark process, make it more reproducible, more transparent, and open to the community. And I'm happy to answer questions on any kind of performance related questions on the ranking. Feel free to reach out to me. And I'm looking forward to your feedback. Thanks a lot.